definitions, some important stuff. I had mentioned this before, but we have things that are called entire radicals and things that are called mixed radicals. So if there is a number in front of the radical, that's a mixed radical. If there is just the radical, that is an entire radical. Here are some other definitions that you will never be tested on, but the whole thing is called a radical. The little number is called the index, and word of the day, the number inside is called the radicand, which just sounds cool. So we're going to find that for a lot of our math, the mixed radicals will be the most helpful. Sometimes the entire radicals are going to be helpful. But for lots of math, the mixed radicals are going to be the helpful. In fact, we can underline this. When it's written as a mixed radical, we consider it to be in simplest form. So you know how you had to always reduce fractions to lowest terms? And you were told that's what it meant to simplify? Well, we have to do the same thing with radicals. You'll be asked to simplify, so that'll mean to write it as a mixed radical. Here's example one. Example one, it says arrange from greatest to least. Non-calculator, you're going to write things as entire radicals. If you have a calculator, then you can just type everything in, see which, as a decimal, which one's the biggest, which one's the smallest. Okay? So A would be an example of a non-calculator one. So what I would do is I would say, okay, 5 root 2's. 5 is the same as square root of 25. So this is the same as writing square root of 25 times square root of 2, which we've already learned we can multiply those together, and that root 50 was part of our root 2 family. 2 root 5's, well, 2 is the square root of 4, and that gives us the square root of 20. And 4 root 3's, well, 4 is the square root of 16. So if we were writing from greatest to least, the greatest one would be 5 root 2, then 4 root 3, and then finally 2 root 5. Part B would also be non-calculator, but this is the first time, like our activity at the beginning was just with square roots. In Part B, we have 3 things that are listed with cube roots. Okay, this is a little bit of a, we have 9 cube root of 2. Oh my goodness. Okay, I'm going to say that their choice of number here, I probably wouldn't put this on your non-calculator part. Does anybody know cube root of what number is equal to 9? 9 times 9 times 9 is big? 729, were you good with that? Is that what was in your head? I'm sure, yeah. Bassam was like, yeah, I knew that. Cube root of 729 is 9, times by cube root of 2. So this will be, as an entire radical, cube root of 1458. Oh, that's the second one. Oh, no. Second one is 11 cube root of 2. Oh, my goodness. This is really stretching my mental math this morning. 11 cubed? 1331? Double check that. Okay. Times the cube root of 2 will give me the cube root of 2662. And then finally, 8 cube root of 2. And 8 times 8 times 8, 512. Okay, please double check these for me with your calculator. And so we get the cube root of 1024. Anybody, did I make any mental math mistakes as I was doing them? Anybody check them? So then from greatest to least, the greatest one is the 11 cube root of 2, then the 9 cube root of 2, and finally the 8 cube root of 2. Oh my goodness. Oh my goodness. So I got so excited about doing mental math. Can you see that there would be a way easier way of doing this one? Yes. Right? Because they're all cube roots of 2. So it's obvious that the 11 is bigger than the 9, is bigger than the 8. So what I just modeled as a thing that happens to students and to everyone is sometimes you start a question without reading the whole question, right? You just start doing something without reading the whole thing. And then you can get bogged down in math or excited about the math, as in my case. But this could easily be done just by looking because they were all like radicals. They were all cube roots of 2. So obviously, if you have 11 of them, it's going to be bigger than having 8 of them, and so on. But in the first example, did you see we had to change things to entire radicals? Because they weren't alike. Root 5s are bigger than root 2s, but it's hard to tell which one is going to be the biggest until you switch it to an entire radical. And then when we get to part C, in part C, when you have things that are different, like we have fourth roots, square roots, and cube roots, this would be calculator. And in calculator, all you would do is you would start with 3, fourth root of 8. Go to your calculator, type in 3, maybe. Oh, it's not responding. If it doesn't respond, I will do it on, oh, it's responding. The fourth root on my calculator can be done by hitting the math button and then going down to number 5 and pushing enter. Oops, that's not what I wanted. 3 times the fourth root, so I go to math, number 5, fourth root of 8, push enter, I get 5.045. When I have 4 times the square root of 2, 4 square root of 2, 5.656. And finally, I have 3 cube root of 5. Again, I can go to my math button. I can either use number 4 with an x, or I can choose the one that has the cube root already. 3 times the cube root of 5, 5.1299. From greatest to least, the biggest one is the 4 root 2. Then the next biggest was the 3 cube root of 5. And the smallest one was 3/4 root of 8. So questions for practice. Number 5, which will be non-calculator, and number 9, which will be calculator. But we are going to go on to example 2 first. So we already learnt previously that if you're multiplying two radicals, like the square root of 2 times the square root of 8 is equal to the square root of 16. We've already learned that if you multiply two radicals, that you can just multiply inside. And that will work if they're both square roots, or even if it said cube root of 2 times cube root of 8 will equal the cube root of 16. This is also true for dividing, right? If you had the square root of 5 divided by the square root of 3, you could write this as the square root of 5 over 3. And you can work both ways. If you started with the 4th root of, let's do one that we can actually figure out. Let's do the 4th root of 7 over 16. I could change this to the 4th root of 7 over the 4th root of 16. And since the 4th root of 16 is a number, because 16 is 2 times 2 times 2 times 2, that makes the 4th root of 16 equal to 2. I could simplify this to the 4th root of 7 divided by 2. Now, historically, there was reasons for wanting to simplify things. Okay? Historically, before calculators, it was much easier to do the 4th root of 7 than it was to do the 4th root of 7 over 16. And it was really easy without a calculator to divide something by 2. That's pretty straightforward math. You guys know how to do that. They no longer teach students how to find the 4th root of 7 or the square root of 8 without your calculator. But that used to be part of a math curriculum. Before calculators, hey, these are square roots. This is how you find a square root by hand. We no longer have to do that because it's too time consuming and we have technology that can do that for us. So math curriculum's always changing to figure out what do you still need to be able to do? What kind of things should you be able to do? And for a lot of the things that you need to do in life, yeah, you have a calculator, but we expect when you get 2 plus 2 that it's like, oh, wait, I gotta pull up my phone, right? Some things we want to be able to do without having our calculator. And big ideas of how things work mathematically, we need to know because the calculator doesn't show us that. So that's what our math curriculum looks like. Okay? So We can divide and we can multiply, which gets us to, did I end the first video and start the second? No. We'll end the first one